Hello guys, awesome that you're here with us again. Today we will start learning advanced techniques of integration, starting by using properties of trigonometric functions for solving integrals involving them. The first three properties that we will learn for solving some integrals are the following. Sine of x times cosine of y is equal to a half of sine of x plus y plus sine of x minus y. Sine of x times sine of y is equal to a half of cosine of x minus y minus cosine of x plus y. Lastly, cosine of x times cosine of y is equal to a half of cosine of x plus y plus cosine of x minus y. For instance, let us say that we want to solve the integral of sine of 3x times cosine of 2x. According to the first property, we know that sine of 3x times cosine of 2x is equal to a half of sine of 3x plus 2x plus sine of 3x minus 2x. All of this is equal to a half of sine of 5x plus sine of x. Thus, the original integral will be equal to the integral of half of sine of 5x plus sine of x. The first one can be solved by using substitution, and the other one is a direct integral. Thus, the result for the original integral will be equal to minus 1 over 10 times cosine of 5x minus a half of cosine of x plus c. For the following integrals, we will require knowing the following properties. Sine square of x plus cosine square of x is equal 1. Sine square of x can be written as 1 minus cosine of 2x divided by 2. And finally, cosine square of x can be written as 1 plus cosine of 2x divided by 2. Let us consider the integral of sine square of x times cosine to the 5 of x dx. Now we're going to rewrite the expression regarding cosine of x. And now we are going to have the integral of sine square of x times cosine square of x squared times cosine of x dx. And by using the fact that sine square of x plus cosine square of x is equal 1, we can solve for cosine square of x and know that cosine square of x is equal to 1 minus sine square of x. Thus, the previous integral will be equal to the integral of sine square of x times 1 minus sine square of x squared times cosine of x dx. And if we perform the substitution, u equals sine of x du will be equal to cosine of x dx. Thus, the previous integral become the integral of u squared times 1 minus u squared du. And if we expand the expression in the square, we get the integral of u squared times 1 minus 2u squared plus u to the 4 du. And if we solve this integral, we have u to the third power divided by 3 minus 2u to the fifth power divided by 5 plus u to the 7th divided by 7 plus c. Let us consider the integral of sine square of x dx. Now, by using the fact that sine square of x is equal to 1 minus cosine of 2x divided by 2, we have that such an integral become the integral of 1 minus cosine of 2x dx divided by 2. Now, we can split this integral into a half of the integral of dx minus a half of the integral of cosine of 2x dx. If we perform the substitution, u equals 2x we have that both integrals become a half of x minus a fourth of sine of 2x plus c. That will be the solution. Now we will consider the following properties for solving other types of problems regarding trigonometric functions. And the properties are the following. Tangent square of x plus 1 is equal to secant square of x. And cotangent square of x plus 1 is equal to cosecant square of x. Now, in order to get these two properties, we only take the expression sine square of x plus cosine square of x equals 1. And if we divide by cosine square of x, we get the first property. But if we divide by sine square of x, we get the second property. Let us consider the integral of tangent cubed of x times secant to the fourth power of x dx. Now, such an integral is equal to the integral of tangent cubed of x times secant square of x times secant square of x dx. Now, secant square of x is equal to 1 plus tangent square of x. Thus, the first integral will be equal to the integral of tangent cubed of x times 1 plus tangent square of x times secant square of x dx. So, if we perform the substitution u equals tangent of x, then du will be equal to secant square of x dx. Thus, the previous integral becomes the integral of u cubed times 1 plus u squared du. Now, if we apply distributive property, we get the integral of u cubed plus u to the 5 du. And such an integral is equal to u to the 4 divided by 4 plus u to the 6 divided by 6 plus c. And we only need to replace u by tangent of x for obtaining the final result. Now, consider the integral of tangent cubed of x times secant to the 5 of x dx. Now, such an integral can be written as the integral of tangent square of x times secant to the 4th of x times tangent of x secant of x dx. Now, if we do the substitution u equals secant of x, we have that du is equal to tangent of x secant of x dx. Now, remember that tangent square of x plus 1 is equal to secant square of x. Thus, tangent square of x can be written as secant square minus 1. Thus, if we apply all the substitution, we get that the original integral is equal to u squared minus 1 times u to the 4 du. By applying the distributive property, we get the integral of u to the 6 minus u to the 4 du, which results is equal to u to the 7 divided by 7 minus u to the 5 divided by 5 plus c. And for getting the proper result, we need to return the change in variables. It's a matter of practice to start recognizing these integrals so you can naturally start applying these techniques. Now, in order to do so, I challenge you to solve the following integrals. And well, as always, see you in the next lesson.